Let's discuss two problems, both using the slow and fast pointers, Leetcode 141 and 142. Both are basically finding if there is a cycle inside the linked list or not. Before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. Now, back to the problem, Leetcode 141. You are supposed to detect if there is a cycle in the linked list or not. So there is a Floyd's algorithm which basically uses a slow pointer and a fast pointer. Slow pointer goes one step at a time, fast pointer goes two steps at a time, and if there is a cycle they will meet, and that's how you will know whether there is a cycle or not. So I call this as a tortoise hare pattern because of the fast is moving like a hare and this one, and they will eventually meet. So you start off with both at the head, slow and fast, and then basically move the fast pointer by 2. So by checking fast is not equals to null and fast dot next is not equals to null, because you need to move it 2 steps ahead, and because you have to dereference this pointer so that if this is null then it will crash. So slow moves to slow to next, and then fast moves to fast at next, and then if slow equals to fast you return true, otherwise you return false. So in this case there is a cycle in this linked list. There is a cycle at 2, so it will be like 2 is the next one if you keep traversing the linked list. And so slow pointer starts at 2, the fast pointer it at 0, it moves 2 steps, and then slow moves to 1 step to 0, and then fast pointer has already moved 2 steps by moving from -4 to 2, and then slow moves to -4, and then fast jumps from 2 to -4, and they meet, and so the cycle is detected. And that's it for 141. For 142 it is exactly similar, but there is a slight variation. You need to tell where the cycle starts, so that's the key. You need to figure it out. So it's exactly the same pattern until this point, where if they check the meet, now you basically start the entry pointer at the head and then move until entry pointer equals to the slow pointer. There is a math working to say why this is the case. It depends on the cycle, how much is the cycle length, and that's how it's the number of times. If you actually take out the offset, like I will take this example, like in this case, like it's a huge list, linked list, but the cycle starts at 9. So 9 and 10 are the cycle, and so I ran this scenario of where so the slow pointer and the fast pointer meet at 9, and now you need to find out where the starting point is, and at this point you start entry pointer at 2, and then see the slow pointer keeps flipping through the cycle, and then because of the offset you have to take it out. Once both of them, the slow and the fast pointer, if they traverse in the multiples of the cycle length, so once you have to take out the offset to reach the entry point, and then what happens is the once you take out the offset, that is the place where exactly within the cycle they meet, because the offset determines where they meet. And so even the when the entry pointer goes one step at a time, even though the slow pointer flips through multiple times of the cycle, because of that offset, they meet at the entry point itself. So it can be mathematically proven, and that's it. Let me know if you still have any comments. Otherwise, I will see you in the next video.